we are going to be discussing end behavior. Now, end behavior is what happens to the function values as x approaches positive and negative infinity. So as x is moving left and right on our graph, we want to know what is happening to our y values. What is happening to the values that are coming out of our function, right, when we plug in those x values. So let's look at these two examples here. Now, we have an odd degree polynomial with positive leading coefficients. So notice that all of these, this one has a degree 1 because x is to the first power. This one has a third degree because the highest power is a 3. This one's a fifth degree because the highest power is a 5. All of the leading coefficients are positive. This one has a leading coefficient of 1, this one of 0.5, this one of 2. They are all positive leading coefficients. If you have an odd degree function with a positive leading coefficient, the end behavior is going to look like this line, like just the line y equals x. Okay, which is what this states right here. And behavior is similar to the line linear parent function f of x equals x. What this means is that as x goes to positive infinity, you can see this here, as we move this direction with x, y is going to positive infinity. Y is also, as x goes this way, y is going up. Now, as x goes to negative infinity, y is going down to negative infinity. All right. So in a polynomial function, if you have an odd degree polynomial function, positive leading coefficient, and you only have this, don't have the graph, then you can know it's going, if it's going off to positive infinity when x is going to positive infinity, and when x is going to negative infinity, it's going to negative infinity in the y direction. All right. Now, the other case here is an even degree polynomial, but with a positive leading coefficient still. Now, you can think of it this way. Even degree, very similar to quadratic. We have a quadratic here, f of x equals x squared. If it's positive, a positive leading coefficient, it's just going to sit pointing up, right? Concave up. So as we move, as x goes in the positive direction to positive infinity, y is also going up to positive infinity. So as we move along the graph, it just keeps going up. As x goes to negative infinity, y is going to positive infinity still. So here those signs don't match. Here they did. Here they do not. Now, these are if we have an odd degree and even degree with positive leading coefficients, okay? Positive leading coefficients, they're just kind of going to follow a regular line or the parabola. They're all going to look like that in their end behavior. They're going to go off in that direction, okay? So recall that a reflection of a function across the x-axis occurs when the function is negated. So for example, let's say that our blue function is f of x and our green function is negative f of x. We've just flipped it. It's a reflection over the x-axis. See how all of these points were just flipped the other direction, all right? So the end behavior of a function is similarly affected when the leading coefficient is negative. As we discussed up here, positive leading coefficients, positive leading coefficients. Now, if you look, when we have negative leading coefficients, see how everything is just flipped? Our line is now moving that direction. Our parabola is now facing concave down. So, odd degree function with a negative leading coefficient, as x approaches negative infinity, as x approaches positive infinity, y is going to negative infinity. So all of these functions, the linear function, it's going down as we move to the right. H is going down as we move to the right. The blue one, g, is going down as we move to the right. Okay. As we go to the left, as x goes to negative infinity, y is going to positive infinity. So that means as we move to the left, f of x is going up. As we move to the left, g of x is going up. And as we move to the left, h of x is going up. All right. Now, even degree functions, it's the same thing. Now everything's just been reversed. As we move to the right, as x goes to positive infinity, everything's going down. As we move, and so it's going off to y goes to negative infinity. As we go to the left, everything is going down as well. So y goes to negative infinity as x goes to negative infinity. All right. Okay, let's look at a little bit of some examples after looking at this concept summary. This might be a nice thing to have on a note card, something like that. Odd degree leading coefficient positive, you're going to have directions going like this. As we go to the right, as x goes to positive infinity, y is going to go to positive infinity. As x goes to negative infinity, y is going to go to negative infinity, etc. Okay, this may be a good place to pause and write that down on a cheat sheet. Now, we're going to describe the end behavior of this function without even graphing it. All right? So this function has a positive leading coefficient. So that means I'm sitting in one of these two cases. Okay? Positive leading coefficient, and I've got an even degree. So I'm sitting in this case right here. If this is the case that I'm looking at, for example 1, this means that as x goes to positive infinity, y is going, or f of x, y or f of x, you can write either one, is going, well, let's see, as we go to positive infinity, we are going up. So we're going to positive infinity as well. And we have that, I'm going to write it below it, and as x is going to negative infinity, f of x, as x goes to negative infinity, f of x is going up as well. It's going to infinity still. So that describes the end behavior of our graph. All right. Now, if we were to go and graph this function, you're welcome to try that in a calculator right here to check it. It doesn't matter really what's happening in here for end behavior. That's the name, end behavior. It doesn't matter what's happening in the center. We just care about what's happening on the ends. What direction is it going? All right. So looking at example 2, we're supposed to describe the end behavior of the function g of x equals negative 5x cubed plus 8x plus 4. Again, you could graph this and see it, but without graphing it, we can determine the end behavior. So looking at this, we have a negative leading coefficient. So we're going to be sitting in one of these two cases with the negative leading coefficients. We have an odd degree, highest power is a 3. So we're going to be sitting in this case right here. This is our case for example 2. So with an odd degree and a negative leading coefficient, as x goes to positive infinity, I'm actually going to want to write this all in a line on this one. So as x goes to positive infinity, y is going to negative infinity. You can see this right here. It's going down. Now notice I've written y here and f of x up here. That's fine. If I were to be writing, instead of y here, I would write g of x if I were wanting to write my function name. Okay. And as x goes to negative infinity, we always have, notice we always have these two. As x goes to positive and x goes to negative. That's how we're matching it up. Y goes to positive infinity. We're going up. All right. Okay, let's describe the end behavior. This is the last example of these two graphs below. So this one, as x goes to positive infinity, we're moving this way. What's happening to my y? It is going up. So I am going off to positive infinity. As x goes to negative infinity, it's a beautiful infinity sign. As x goes to negative infinity, I am going up. So y is going to positive infinity. This would mean, looking at our cheat sheet up here, our little concept summary, that since we look like this, this is an even degree polynomial with a positive leading coefficient. So it might be to the power of, well, it's not going to be to the power of 4, but it's going to be the power, it might be to the power of 4 actually, might have other terms. It's going to be an even power with a positive leading coefficient, all right? It would be facing down like this if it were a negative leading coefficient. Now, looking at this one over here, we have as x is going to positive infinity, right here, we are going up. X is going to positive infinity, so y is going to positive infinity as well. As x goes to negative infinity, y is going down. So y is also going to negative infinity.